Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and welcome back again to our online class. And today we are going to discuss a new topic, and the topic is called differential equation, and by using numerical method. So, okay, for the ease of our explanation, I want to remind you, so this is brainstorming. Uh, Before we go to differential equation, I just want to remind you with some concept. So let's talk about the equation. Okay, so this is the equation, and I have an example here. So I have y equals to x plus 1, and then uh, we want to know the value of this. Okay, um this is 0. Okay, so y y0 here, so it means that this is the x. Okay, this is x. So uh this expression, okay, so this expression means uh whenever the value of x equals to 0, then the value of y is, we don't know, because we don't have the solution of this expression. So we are going to solve this equation. Okay, so the value of x is 0, so we put 0 here, and then plus 1. So this is y. Okay, so our y is 1. Yeah, so we put this number 1 into this. Okay, so the value of y 0 equals to 1. Yeah, so this is the x, and then this is the value of y. So this is called equation. Okay. Okay, let's move to another page. Okay. We already discussed about the equation. Now I'm going to remind you about the differential differential equation. Okay. In previous pages, in previous page, uh, the term is only called equation, but now in this page, not only just equation, but also we have differential equation. And what is the difference between ordinary equation or just equation with this differential equation? Okay, so I have this expression. So this is dy power dx equals to x to the power of 2 plus 1. So if the equation is just ordinary equation, we only have y. Okay, we only have y. But in differential equation, we have dy per dx, and this is called the differential expression. Differential expression. That's why the equation called differential equation. Okay, so we have this expression, and then we are going to find the value of y. um, y, let's say y1. Okay, y1. Okay, but because this is the differential equation, we have initial value. Okay, this is initial value, and the initial value is y 0 equals to 1. So it means that when the value of x equals to 0, then the value of y is equal to 1. Okay, and we're going to find this value. Okay, yep. And what we are going to do is finding the solution of this, and I will write down again the equation. So dy per dx equals to x to the power of 2 plus 1, and then this is dy x to the power of 2 plus 1, and the dx move to here. Okay, so this is dx. Yep. And because this is the differential, and also this is the differentiation or differential, then if we want to know the value of y, so we have to integrate. Okay, integrate this expression, and I get this is y. So the integration is oh, I'm sorry, 1/3 x to the power of 3 plus x plus c. Okay, so this is the solution. But the problem is we don't know the value of c. So we go back to our initial value. Okay, we have this. So when the value of x equals to 0, then the value of y equals to 1. Okay, so when the value of x0, then y1. Okay, x0, the y is 1. Okay, so we put the value of 0 to the x. Okay, to the x, and we put the value of y to y. Okay, and then we got this. This is 1 equals 1/3. Our x is 0, so 0 to the power of 3 plus x again, so we have 0 here, so this is 0 plus c. So this is 1, this is 0 plus 0 plus c. So the value of c is 1. Okay, and because we already find the value of c, then our equation will be y. Okay, I will use another color. Okay, so we have this y equals to 1/3 x power to the power of 3 plus x plus c. So this is 1. Okay, so we have the solution for our differential equation, and now we are going to find the value of this. Okay, so it means that when the value of x equals to 1, then how much the value of y. Okay, so we are going to put the value of x equals to 1 into our solution. Yeah, so we have um, x equals to 1, then y to the power of 3 plus 1 plus 1. So this is 1/3 plus 1 and plus 1, and it will be equal to 1 plus 3 plus 3, and then this is 7/3. Yeah, so this is our answer to our problem. Yeah, so we have this is y1, so y1 equals to this. Okay, to this. Okay, so I will write down it again. Y1 equals to 7/3. Okay, and we found the value of y1, but we use very long calculation from this to this, and we put integration here. So this is kind of analytical method. Okay, this is just analytical method, and in this session I would like to show you how to find the solution of this differential equation by using numerical method. And why we have to find the why do we have to use numerical method? Because sometimes uh, our equation is not as simple as this. Okay, I will show you. Okay, I will go to another page. Okay, so this is example 1. Example 1, and then this is example 2. Okay, for this example 2 I have this expression dy per dx equals to 1 per x. Okay, and initial value we have y0 equals to 2. So it means that when the value of x equals to 2, then the oh, I'm sorry, when this is the x, so when the value of x equals to 0, then the value of y is 2, and we are going to find the value of this. Okay, now we are going to find the solution of this. Okay, so I will make this the dx move to this point, to move this part, this session I mean, so it will be dx, then because I want to find the value of y, then I have to integrate this. Yeah, and then the integration of 1 per x equals to ln x plus c. Okay, and the integration of 1 per x equals to ln x is theory, so you can just, is a kind of formula, so you can just remember it. Okay, now we are going to find the solution of this. Okay, now we put our x here, we put all this expression into this expression. So we have when the value of y2 equals to 0. Okay, y y y0 y0 equals to 2. Yeah, so this is the x. So y equals to 2 ln x. Our x is 0 plus c. Okay. So do you guys know what is the value of ln 0? So the value of ln 0 is unidentified. Okay, so this is the problem. Sometimes we have expression that cannot be solved using analytical method. So we can use numerical method to solve this kind of equation. So using analytical method, analytical method cannot be used. So we move to numerical method. Yeah. And how to use the numerical method, I will explain you on the next video.